In this video, you will learn all about quadratic functions. Now, what is a quadratic function? Well, a quadratic function is a function that can be written in the form of f of x equals ax squared plus bx plus c. With a function like this, the graph will be a parabola, meaning it's going to be a shape like this, or it could be upside down like this. All right, that would be a quadratic function, something like that. And notice that with a quadratic function, we need an x squared term. So we need at least one term with x raised to the second power. All right, so anything like that would be a quadratic function. So it could be something like f of x equals 2x squared minus 4. Or it could be f of x equals negative x squared plus 2x minus 3. Anything like that would be a quadratic function. Now let's talk a little bit about the graph of a quadratic function. So the graph of a quadratic function will first of all have a vertex. So the vertex is going to be the lowest point of a parabola that opens up or the highest point of a parabola that opens down. So for example, if we had a parabola opening up, the lowest point right here, that would be the vertex. If it was opening down like this, the lowest point, or the highest point here would be the vertex. All right, so depending on which way it's opening, it's going to be the lowest or the highest point of the parabola. Next, we have what is called the axis of symmetry. What this is a vertical line through the vertex, and if folded on this line, the two halves of the graph would line up. So for example, with this first graph, if you were to create a line like this, going right through the vertex, that line would be the axis of symmetry. Same thing over here with the one facing upside down. If you make a line like this, right through the vertex, that would be your axis of symmetry. Because with both those lines that we created, notice the left and the right side of the parabola are identical. All right, so it is symmetric with respect to that line. So if we say it's symmetric with respect to a line, what that means is that for each point P on the graph, there is a point P prime on the graph such that the line is a perpendicular bisector of the line segment P prime. Okay, it's kind of wordy, and what does that mean exactly? Well, let's draw our parabola again. All right, we said it was symmetric with respect to this axis of symmetry. So what that means is if we have point P, let's say we put it right here, then there is a point P prime that exists over here in this case, such that the line that cuts it in half would be a perpendicular bisector of the line segment P prime. So notice I'm sketching this out, so it's not going to be exactly accurate as far as the distances and things, but the idea is this axis of symmetry is going to cut this line in half in a perpendicular manner. All right, it's going to be a perpendicular bisector of P prime. And that goes for any point. If we pick this point here, we'll call it Q, then if this parabola is symmetric with respect to this axis of symmetry, then there's going to be a point over here called Q prime that corresponds with point Q, such that if you were to create a segment connecting Q and Q prime, this axis of symmetry would cut this line in half. All right, so that's the idea of being symmetric with respect to a line. And here also, the graph can be folded in half along this line, and the two halves will perfectly line up with each other. All right, so we saw that with the picture. Okay, if you imagine folding this in half, all right, the left side and the right side would line up completely with each other when you fold it in half like that. So that's your definition of being symmetric with respect to a line. And with the parabola, that line that is symmetric to, or with respect to, is called the axis of symmetry. Now with parabolas, we have what is called standard form. Your standard form of a parabola is this right here, where we have f of x equals a, some number, times parentheses x minus h, where h is another number, squared, and then plus k, where k is another number. So when it's in this format, what we can tell really quickly is the vertex, first of all. The vertex would be h, comma, k. This number here with the x in parentheses is your horizontal shift, and this number out here being added or subtracted is your vertical shift. All right, so for example, if we had f of x equals, let's do 3 times x minus 4 squared plus 6. Okay, your vertex can be determined by the number here. So we take the opposite of this, that's negative 4, so you make it positive. All right, and then this right here is your vertical shift. That's going to be your y value. So your vertex in this case would be 4, 6. Well, we can also tell, looking back over here in the standard form, we can also tell the axis of symmetry. The axis of symmetry is the vertical line that cuts through the vertex. And that line, that equation, is going to be x equals h. All right, so looking back over here, your axis of symmetry, we'll just call it axis for short, your axis of symmetry would be x equals 4. All right, if we kind of sketch this out, here's what we're going to have. Okay, it goes to the right 4, up 6. So it's going to be like that, and it's going to be facing up. We'll explain that in a moment. Your axis of symmetry is going to cut right through here, and the equation of that vertical line, that equation is going to be x equals 4. All right, and the vertex would be at the point 4, 6. Now, one more thing we can also tell from standard form is with this number in the front. Okay, if it's greater than 0, so if it's positive, that means the parabola is going to open up. If it's less than 0, so if it's negative, the parabola is going to open down. So that's how I knew it was going to be facing up, is because this number in the front of the function that we gave you, that is a positive number. So it's facing up like this. So you can sketch very quickly the graph of the parabola when it's in standard form like this. And by the way, it's worth pointing out that you could have times where you have a function and there may not be anything in parentheses. It might be like negative x squared plus 4. Well, if that's the case, there's an assumed 0 being added with the x. All right, so your x value is going to be 0. There's no horizontal shift, and 4 is your vertical shift. So your vertex in this case would be 0, 4. And then your axis of symmetry would be x equals 0. All right, and then because it's negative in the front, we know that it's facing upside down. So there's a lot of information we can tell just based off this standard form. Now, what if it's not in standard form? What if you're just given a function like this, where we have y equals x squared minus 2x minus 5? Well, what we need to do is get it in the format where we have something in parentheses squared, and then plus or minus some number out here. All right, so what we can do is we can basically take your equation or your function. All right, we kind of put the negative 5 over here off on the side because, see over here, we need the constant off on the side. What we're going to do is we're going to leave a little blank, because what we're going to do is we're going to add a number here in this parentheses that we just created. We're going to add something here to make this into a perfect square. Now remember, we've done this before with the process of completing the square, which is what we're going to do right here. So the number we need to add is found by taking half of this number and then squaring it. Half of negative 2 is negative 1. Negative 1 squared is plus 1. So we add a 1 right here. Now keep in mind, typically, or normally when we do equations, you cannot just add a number without doing it to the other side, right? So what we need to do is we need to add 1 to the other side, right? So add a 1 over here. But our goal is we want it to be y by itself, right? We want y equals something. So you can add a 1, but eventually we're just going to have to subtract it over to this side to get y by itself. So instead of going through the process of adding 1, subtracting 1 on this left side, we can just realize that, hey, if we're adding 1 right here, we can counteract that plus 1 by subtracting 1 on the same side, right? Because if you add 1 and subtract 1 on the same side, that's the same thing as adding 0. So we're changing the way it looks without changing the right side value. So now from here, in this parentheses, we have a perfect square trinomial. That would be x minus 1 squared And then we have negative 5 minus 1, which would be negative 6. So we now have our equation in standard form. Now we can tell very quickly the vertex. The vertex would be the opposite of negative 1, which is positive 1. That's your horizontal shift. Negative 6 is your vertical shift. So your vertex would be at 1, negative 6. And then if we wanted your axis of symmetry, we'll just abbreviate as the word axis. Your axis of symmetry would be x equals 1. It's this x value. And then if it's opening up or down, we can determine that because the number in the front is an assumed 1, positive 1, so it's going to be facing up. So it's opening or facing up. And if you wanted to sketch that really quick, we could. The vertex would be over 1, down 6. That takes you to this point right here. All right, that's your vertex. And then it's facing up. All right, so it's opening up like this. So we're not getting this exact, but we're just sketching what the picture would look like, just kind of in general. So it's going to have these features. This vertex opening up. And the axis of symmetry, if we wanted to create that, that is the line, the vertical line right here that goes through that vertex. So that's the equation of the axis of symmetry. Let's try another example. Here we have y equals 2x squared plus 36x plus 170. All right, so this one, okay, we need to put into standard form to be able to graph this quickly. So if you're trying to put this into standard form, again, we're going to have to kind of separate. So we're going to have to separate the 2x squared plus 36x from the plus 170. So just create a little space. You're going to put a blank here, and then put parentheses here. Now before we can complete the square like we did in the last example, we need to factor this number out because we want the x squared term to have no coefficient. We want the coefficient to be an assumed 1. So we factor a 2 out of just the parentheses, not the 170, just the parentheses. So we pull a 2 out, and you're left with x squared plus 18x. And again, do not touch the 170, leave it over here. All right, so now we have this. And then we can add something here to make this parentheses into a perfect square trinomial. That number we want to add is determined by taking this number. We take half of that and then square it. Half of 18 is 9. 9 squared is 81. So we're going to add 81 here. Now we can't just add 81 without doing something to the equation to keep it balanced. Now, keep in mind, when we added 81, there was a 2 in front of the parentheses. So in reality, when we added 81, we actually added 2 times 81, which was 162. So we actually added a 162. So to counteract that, we need to subtract 162. All right, so now what we have is y equals 2. Parentheses would be x plus 9 squared. It's a perfect square trinomial. And then we have 170 minus 162, which would give you a plus 8. So this would be our equation written in standard form. All right, and from here we can tell very quickly the vertex. So the vertex would be the opposite of 9. That's negative 9. That's your horizontal shift. 8 gives you your vertical shift. That's going to be positive 8. So your vertex is at negative 9, positive 8. Your axis of symmetry is the vertical line going through the vertex. That would be x equals negative 9. And we know because this number is positive, that's a positive 2, it's going to be opening up. All right, so that's going to be your information about the graph. All right, so we see everything typed up here. The vertex would be over 9 and up 8. And if we just do this as increments of 2, so like 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, 12. So if you do it like that, we go over, we said go over 9, so about right here. And then so go over 9 up 8, which takes you about here. All right, so it's going to be right here, opening up. So it's going to look like this. All right, so that would be the sketch of your parabola. So we could go through all these steps to find the vertex and then figure out if it's opening up or down. But there's actually a quicker way to find the vertex. So if you're just given an equation like this here, so if you just have an equation given to you and you are trying to find just the vertex without having to complete the square, what we can do is we can use what is called the vertex formula. So as a quick way to find the vertex. So the vertex of a function, so f of x equals ax squared plus bx plus c, is, and here we see the x value is going to be negative b over 2a. So we take the x value, we can find that by using negative b over 2a, and then once you find your x value, you plug it in for x, negative b over 2a, plug it into x for the f function, and figure out what you get for y. So you find x, and then once you find it, plug it in to find y. So what does this look like? Well, what if we had f of x equals negative 6x squared minus 12x minus 13? So to find the x value, we can do x equals negative b over 2a. All right, so that's going to be your equation. All right, and the negative doesn't matter if it goes with the b or on the outside. That doesn't make a difference. But negative 6 would be your a value. Negative 12 is your b value. So we have a negative 12 over 2 times a, which is negative 6. So that gives you positive 12 on the top, negative 12 on the bottom. 12 divided by negative 12 is negative 1. So your x value for the vertex is going to be at negative 1. Now to find the y value, we take that same function, just plug negative 1 in place of x to figure out what is y. So just plug in negative 1. We have negative 6 times negative 1 squared minus 12 times negative 1 minus 13. So negative 1 squared is positive 1. Negative 12 times negative 1 is positive 12, and then minus 13. So we have negative 6 plus 12 is positive 6, minus 13 is negative 7. All right, so your y value, f of x, is your y value. That's equal to negative 7. So we found the vertex. The vertex is negative 1, negative 7. So we can quickly find that point. Okay, we can graph that. And if you graph that vertex, it would be over 1, down 7, right here. And then we can tell which way it's opening, because if a is bigger than 0, it opens up. If a is less than 0, it opens down. And a is going to be this number right here, the negative 6. So because it is less than 0, that means it's opening down. So it's going to look something like this. So we can verify that. We can, if we went through the same process of taking this, this function and putting it into standard form, we would find our function to be right here, negative 6 times x plus 1 squared minus 7. And the vertex would be the same. It would still be negative 1, negative 7. So this vertex formula is a quick way to find the vertex without needing to go through the completing the square process. Now another thing on the topic of vertex. The vertex is going to be at the highest or the lowest point of the parabola. Now the highest or lowest point is called a maximum or minimum value. So it's a maximum value if it's the highest point on the graph, and that's the case when the parabola opens down. So if a is less than 0, so meaning it's a negative number in front of the x squared term, is opening down like this, and the vertex in that case would be a maximum point. And then if it's a minimum point, that means it's going to be the lowest point on the graph. So if it's opening up like this, okay, then the vertex would be the minimum point. And open upwards like that, a is going to have to be positive. A must be bigger than 0. Now this would be important to know if it's a maximum or minimum value, because if you need to determine the range of a quadratic function, we need to know which way is it opening, up or down. So if we're trying to find the range of a function, we need more than just knowing if it's opening up or down. We need to know at what point is the vertex. So here in this example, we want to find the vertex to figure out where that point is going to be, and then determine if it's opening up or down, and then from there we can figure out the range. All right, so to figure out the vertex, we have to plug in negative b over 2a to find x, and then we have to plug that value in for x, plug that into x to figure out what is y. So here a is going to be negative 3, b is going to be positive 12. So we have negative 12 over 2 times a, which would be 2 times negative 3, or negative 6. So we have negative 12 over negative 6, which gives you positive 2 for x. So x is positive 2. Okay, now y, you plug a 2 in for x, and you can solve for y. So we have negative 3 times 2 squared plus 12 times 2 minus 10. That would be negative 3 times 4, which is negative 12. And then plus 12 times 2, that's 24. Then minus 10. So negative 12 plus 24 is 12. 12 minus 10 is 2. So y would also equal 2. So putting that together, your vertex would be at the point of 2, 2. All right, so the vertex is at 2, 2. We'll kind of sketch this out quick. It goes over 2, up 2. So it's going to be at this point. And then here, because a is a negative number, it's opening down. So from that alone, because it's negative, we can tell it's opening down. So this vertex is going to be a maximum point. Okay, it's a maximum value. Now, our question though is to find the range. Remember, range means y values. So what are values of y that hold true with this function? So what are our possible values for y? Well, notice here, y is up and down on a graph, right? So at this point, okay, y would equal 2. And then y can be 2 or anything less than 2. Y, you don't see y up here. You don't see any points above 2, right? So our y values will be at 2 and anything below 2. So we can state that as y is less than or equal to 2. So this would be your range. Y is less than or equal to 2. That is the possible values for y with this function. So if y were up here at 3, if it was over at 2, 3 as your vertex, then it would be y is less than or equal to 3. So you find the y value, and then figure out if it's opening up or down, and use that to find the range. If it was opening up, by the way, it would be y is greater than or equal to 2. So you just have to look at each scenario to determine the range. So we've learned all the mathematics behind quadratic functions for this lesson, and now we're going to talk about some applications of this. Well, parabolas can be used in many different contexts. One main context is physics. So if you were to have a projectile, so anything that you throw or kick into the air, it's going to make a parabola like this. So that's one application, is with physics, but we also have other applications as well. So here's one example where we are told that Sue is building a little rectangular rose garden against the back of her house with the fence around it, but she only has 120 feet of fencing available. What would be the dimensions of the garden, with one side attached to the house, to make the area of the garden as large as possible? So to answer this question, it is going to require a quadratic function. All right, we'll get that function in a moment. But once we have our quadratic function, we're trying to figure out the largest value of something. So what we're trying to find with most of our applications is going to be a maximum value or a minimum value. So we're going to need to find the vertex many times for the parabola. Now in this particular example, let's figure out what the function is going to look like. So if it's helpful, you can draw yourself out a picture, something like this. So the house is on one side. So we are not putting any fence right here along the house because the house is serving as one of the walls. All right, but we are going to put fencing here in red. All right, so this would be our fence. So with the fence, we have the width, and then we have the length. Now this length, we can write this as something in relation to the width. All right, so we want to keep the variables to be the same. Instead of having two variables, we can just write it with one. So how can we write the length in respect to the width? Well, we can use the fact that there's 120 feet total of fencing. So if we have 120 feet of fencing and we use up W amount here and then another W amount over here, what we have remaining is going to be 120 minus the 2 W's. And that would be the length. The length would be 120 minus 2W. So now from here we can figure out an equation. So for rectangle, the area is going to be length times width. And we know we're dealing with area because it says we're trying to make the area as large as possible. So we're going to use the area formula, length times width. So we take 120 minus 2W and then multiply it by the width, which is W. So from here we can distribute. We can multiply the W by 120 and by negative 2W. That would give you negative 2W squared and then plus 120W. So this is our quadratic function. We have a term or a variable being squared, so it's quadratic. Now if you graph this quadratic function, we know because of the negative 2, because a is negative, it's going to be opening down like this. And so we're trying to find this vertex right here, because this vertex is made up of an x and a y value, and in this case it's going to be W. W is your independent variable, and then your y value or dependent variable is going to be your area. That's capital A. So at this point right here, okay, that's going to be the maximum value for y. Okay, A is going to be maximized at this point. So the question is, at that point, what is W? Right? And that's what it's asking. It says, what are the dimensions of the garden to make the area as large as possible? So all we're really concerned about is really the W value. Well, how do we find the W value? We can use our vertex formula to do that, where the variable, this W, is equal to negative B over 2 times A. So A is negative 2, so we have a negative 2 over, sorry, A is negative 2, but we need negative B, so negative 120 over 2 times A, so 2 times negative 2. So what we have is going to be negative 120 over negative 4, which would be positive 30. So W at this point is going to be 30. So W is 30, and that's really all we were concerned about. We could find the area by using our function right here, but we don't really need that to answer the question that we're trying to find. Just want to know the dimensions. So W is 30. That would be here and here, but we do also need the length. So 120 minus 2 times W, so 2 times 30. That'd be 120 minus 60, which is equal to 60. So this length would be 60. And we could actually find the area very quickly now that we have the width and the length. So the width is 30, length is 60. Area would be 30 times 60, which is 1,800. So it'd be 1,800 square feet. All right, so that's one application of these quadratic functions. Let's take a look at one more application. Here says the profit from selling local ballet tickets depends on the ticket price. They find that the profit can be modeled by the function p of x equals negative 15x squared plus 600x plus 60, where x is the price of each ticket. What is the ticket price that gives the maximum profit? And then what is the maximum profit? All right, so here we have a function. Okay, this function, if we were to graph it, would be a parabola. It'd be facing upside down like this. And we know that because a is negative. So it's facing upside down, and the vertex here is going to be a maximum point. That point is made up of x and then p of x. All right, where x is representing the price of the ticket, and then p of x is the profit of the tickets. So we can find x and p of x to answer the question of the ticket price, and then use the ticket price to find the maximum profit, which is your y value. All right, so to do this, we need to find the vertex, right? So we can use our vertex formula of x equals negative b over 2 times a. So a is negative 15, b is 600, So we have negative 600 over 2 times negative 15. So that gives you negative 600 over negative 30, which would be a positive 20. So x is going to be positive 20. Now to find p of x, we plug in that positive 20 in place of x. So now we have negative 15 times 20 squared plus 600 times 20, and then plus 60. So that's going to give you negative 15 times 400 plus, and then 1200. No, sorry, 12,000. We need 3 zeros. 12,000, then plus 60. So now we can calculate this. This would give you negative 6,000 right here, and then plus 12,000. That gives you a positive 6,000. And then 6,000 plus 60 would be 6,060. So we have our x value and our p of x value. That's going to be the point 60, comma, and then 6,060. No, sorry, 20, not 60. So we have 20 and then 6,060. So how do we interpret this? Well, remember 20, this x value, is the price of each ticket. So we sell it for $20 each ticket, and that will give us the maximum profit, which is the 6,060. So 20 is the ticket price, and 6,060 is your maximum profit. And that concludes our lesson for today. We will see you next time.